Hey guys, so this is a new unit on energy and how energy is being transferred and transformed. So let's have a look at the learning objective for today. We're going to look at something called a perpetual motion machine and look at how that actually works and try to think about energy and how it interacts with a machine like that. Just a thought out there. Energy, it seems like an amazing thing that you can kind of utilize and get it to work for you. Have a think and see what kind of energy have you already used this morning. And wouldn't it be beautiful if we just have an endless supply of energy? Because if you think about it, it seems like the petrol that we're using for our cars, our electricity, a lot of that is actually energy that you can eventually use up and it's not going to be regenerated. There are some other energy that seems recyclable or reusable. For example, water and sun, that kind of energy. However, you know what? Light energy can also run out. The sun will not have unlimited supply of light energy. And the movement of air, which creates wind that powers your windmill, may not also be present. So, is it possible to have endless supply of energy? Can you create energy that would create more energy and just, repeat itself? Let me introduce you to this concept.
Around 1159 AD, a mathematician called Bhaskara the Learned sketched a design for a wheel containing curved reservoirs of mercury. He reasoned that as the wheel spun, the mercury would flow to the bottom of each reservoir, leaving one side of the wheel perpetually heavier than the other. The imbalance would keep the wheel turning forever. Bhaskara's drawing was one of the earliest designs for a perpetual motion machine, a device that can do work indefinitely without any external energy source. Imagine a windmill that produced the breeze it needed to keep rotating, or a light bulb whose glow provided its own electricity. These devices have captured many inventors' imaginations because they could transform our relationship with energy. For example, if you could build a perpetual motion machine that included humans as part of its perfectly efficient system, it could sustain life indefinitely.
Okay, so those were some examples of perpetual motion machines. And here I have an example for you as well. So this is a very ancient sketch design of a perpetual machine. And what I want you to do is, based on the video that you just watched, what is a perpetual machine? So write down what you've just learned, and then have a look at this machine, and I want you to answer the following question. Describe in one sentence what is the purpose of this machine? What kind of work it is designed to do? All right, so pause the video and write that down. Observe carefully in your notes. Assuming that you've written that down, now I want you to observe the components inside that machine very carefully. And I want you to draw a model and explain how this design is supposed to work to perform the function that you just written down. And if you look closely, and I've already highlighted and labeled it for you, there are 4 major parts in this machine. And component 1 to 4, each does a different function, all right, for that machine to work. Now, I want you to draw a conception model and try model what kind of matter and what kind of energy flows in and out of the machine or flows through each of the components in order for it to perform its designed function. I know that not all of you are going to remember what a conceptual model is. So that's why I've included a PowerPoint for you. And this PowerPoint is going to give you information on some of the basic details of models. Now, I will also go through it briefly with you. If you remember in Unit 1, or maybe you don't, when we talk about a system is something that performs a certain function, and it would have a boundary that kind of defines a space of the system. And then it will have components, which are the bits and pieces, the compartments inside the system that can interact with each other. And each of the component has its own little function that together they're going to perform the overall function of a system. And then we also have inputs and outputs. That's something that goes in and out of the system, or it can go in and out of a component. And these inputs and outputs can be in the form of matter, or it can be in the form of energy. And we did talk about the 4 different types of model. It could be physical, mathematical, conceptual, and simulation. Now, the easiest for us to create is conceptual model, because it only uses boxes and arrows to show how things work. It's best for showing how components interact with each other. So in the model that you're going to do for me, the largest box will indicate to me the system boundary. And then the little smaller boxes are supposed to represent the components in a system. And arrows of input and output will show me what kind of material or what kind of matter or energy is entering and leaving the system, or entering and leaving the component. All right. Now, I don't need you to put long annotation as to what you think this thing is going to do. We have that for later. We're going to save it for later. Just to remind you, systems in physics can be open or closed. When you say open system, it means that both matter and energy is being exchanged with its surrounding environment. It can enter and leave the system. Whereas if you have a closed system, only energy can enter and leave. The matter always remains within the system. It never leaves, it never enters the system. All right. So do's and don'ts when you're doing your model: use only words, use only arrows and flows, and use only boxes. Do not give me a labeled diagram where I have arrows pointing to a box and explaining in paragraph what that box is supposed to do. Now, to add it on this model, so I don't want you to draw it by hand because I want to be able to look at it and comment on it. If you click on the model, this little tab is going to appear at the bottom left-hand corner. So I've created the model, or the basic structure of the model, for you using Google Draw. So if you click on it, here's the edit button. And if you click it, it will allow you to edit directly. And any changes on edits that you've done to it will just come up in the diagram. So pause the video and do that for me. Assuming that you have completed your model with simple annotations, simple arrows, I want you to now think about the independent function of each of these components. Are they transferring and transforming matter and energy? Because matter and energy can be transferred or transformed. Transferring means moving it from one place to another. Transforming means you're changing the form of the energy or changing the form of the matter. So think about what you did, and I want you to write down the functions of each of these components. For example, component 1 transferred the energy on this thing into this kind of energy. So that's an example for you. And once you've written down all of the function, I want you to answer the very final question. Remember, perpetual machine is designed to function and operate forever until the end of time once you got it started. So do you think this perpetual machine can do that? Why and why not? Explain your logic, explain your reasoning and rationale. And once you've done that, that's the end of this asynchronous lesson. Congratulations. And I hope you're enjoying your Easter holiday. I'm looking forward to seeing you back at school and enjoy your presents. I will see you. Bye.